second. So we have cosine of x is sine minus 2, sine of x minus 2 equals 0. So now I'm down to a factored form, which means those two individual parts have to be set equal to 0 to solve it. So I'm either going to have the following: cosine of x equals 0, or sine of x minus 2 equals 0. When I get down to that part, it's just a matter of figuring it from there. So now, when I have cosine equal to 0, where does cosine equal 0?
If x equals 0.
If x equals 0. So where does x equal 0? Well, you were buying it. You were going for it for a second there. Think about your unit circle.
At 2 pi.
Pi over 2,
That's
and 3 pi over 2. Okay? So I know that cosine is going to equal 0 at pi over 2, or 3 pi over 2. Where is sine going to be equal to 2?
X
Nothing.
equals 2.
Nope. No solution. There's a no solution on that one.
So you just get the cosine part?
Yeah. So there's a no solution on that other part. So the only true zeros there are at pi over 2, 3 pi over 2. What's that?
So when you solve something like this, you can't add two cosines to the 0 and then divide by cosine. That's actually solve the 0.
Yeah, because it's like kind of the same idea when you're working with factoring out and finding zeros on parabolas. You're doing basically the same thing. Yes, sir?
I did that a little bit differently to where I added a cosine.
That's what you're saying. You will get through on that one as well, but
But
then
what I got for the final answer was that x equals the inverse tangent of 1. Because you take a cosine and then two cosines, then you divide everything by cosine, and you would end up with sine and cosine, and then you would divide everything by sine.
no, you're making, yeah, you're just moving stuff left and right there, man. That's not gonna work. All right. What was, I forget which other one had to go with the factor right away. 26 you had to factor also. But this one on 26, it's going to give you a little bit more of something that's going to work, if I'm not mistaken. In this case here, both terms here have a cosine in common. Factor out the cosine. We get root 2 times sine of x minus 1 equals 0. My two individual terms then become cosine of x equals 0 and sine of x equals 1 over root 2. I add 1 divided by the square root of 2 just to move it right off the bat. Okay. Again, where was cosine equal to 0? I think this was a general solution, so we'll go back and label that out here in a second. So we know it's at pi over 2, 3 pi over 2. In the sine being 1 over root 2, do I need to rationalize that to figure out what triangle I'm in?
45, 45.
So 45, and it's pi over 4. So I know that this one's going to wind up being sine at pi over 4. Where else is sine positive?
3 pi over 4.
Very good. So again, when we're looking at these problems for this solution, it's asking us to be in general. Okay? So where cosine of x is going to be equal to 0, we all agree it's going to happen at pi over 2 and 3 pi over 2 each time. Right? So what's really the only answer I needed to write down?
Pi over 2 plus pi.
Pi over 2 plus pi n. The general solution in this case here is that if I'm going to be here, if I add pi in here, if I add pi in here, if I add pi in here, it's going to go back and forth. So here my general solution would just be pi over 2 plus pi n. I don't have to tack anything else there. On the other one, to go from pi over 4 to 3 pi over 4, but then I have to come back around again, there's no constant value of adding pi to get me back and forth between these two. So for the general solution in this case, I'd have to write it out as pi over 4 plus 2 pi n, and then 3 pi over 4 plus 2 pi n. Does that make sense, how it doesn't have anything more generic than that? And that's what we're looking at. Okay? If it asks you to find it within one revolution, you would just list out all those answers without having to do any of the general, without having to add on anything. So if it was an interval problem, I would have written both those down and just continued on my way. Which other one was a factoring problem? I think in that first grouping, I think those were the only two you had a factor. If I'm not mistaken.
Can you do 40?
Did you have to do one on 27 as well?
Yeah.
Oh, with the two sign squared? Oh yeah, did I give you guys a trick on that one? I thought I gave you the trick on that. Didn't I?
Didn't X equal some number like
I showed you guys that U thing. Yeah, let's go back and look at that.
Well, you
You showed me after class, or you showed me in class. Okay, that's what it was.
What is that? I like my
Yeah. Something different. He means well. All right, take a look here. In this case here, we have a sine squared, a sine, and then a constant. This is kind of playing the same rule along the lines of x squared x and a constant if you're going to factor that. Do you agree? What happens in math is that you can do something called U substitution. Basically what that means is the following. I'm going to let U equal sine of x. What this allows me to do is to clean up some of the work that I'm about to do. By using substitution, I can say that 2u squared minus u minus 1 is equal to 0. Now I can factor it a little bit cleaner. All I'm doing in this example here, guys, is allowing myself to factor something without all that other garbage in there. It just becomes a little bit cleaner. You use this a lot, pre-calc and calc. You use this all the time. It's called U substitution. It's just making it look a little bit cleaner. So now I have 2 times negative 1. There's negative 2. Add together to get negative 1. What times what's negative 2? But you add them together to get negative 1. Negative 2, positive 1. 2u squared minus 2u plus u minus 1. And now I factor by grouping. Take out your GCF. So the two terms within the parentheses would be 2u plus 1 and u minus 1. That would be the factored form of that. We okay with that? Factoring is a skill that does not go away. You will see it over and over again. But now, what was u equal to? Sine of x. So what I've done here again is I just factored it a little cleaner to rewrite it as 2 sine of x plus 1 and sine of x minus 1. That's all I did. This u substitution just makes it look cleaner to factor. That's all. It's a very, very, very common thing. You see it quite often. Sometimes people just use x, sometimes whatever, but it's called u substitution. Okay.
I just don't think.
Yes, sir.
I just factor out sine. If you do that also, then
Yeah, you could do that.
sine of x equals well, just sine one.
Yeah, because you'll still wind up with the same solution set out there. Okay. This is a nice trick as things get a little bit more complex, though. All right. So now you have your 2 terms, set them both equal to 0.
I just don't.
I have sine of x is going to equal negative 1/2, and sine of x is equal to 1. Okay. What triangle is going to get me to the negative 1/2 for sine? The 30/60. Which angle is it? So it's at the 30 degree, but sine being negative, which quadrant does it drop to? Fourth and third. So my reference angle being at 30 degrees is what? Pi over 6, very good. So I know this is going to be at pi over 6 for the reference angle, but I want it to be negative, so I'm here, and I'm here, so that's 11 pi over 6. Oops. And over here, it's how much? How much? Very good. Those are my solutions there. This was a general problem, if I'm not mistaken, right? Is there any commonality between 7 pi over 6 and the 11 pi over 6 at all? So for both of those solutions, what do you have to tack onto them? Plus 2 pi in. Everybody okay with that? To get us all the way back around again? Now, sine of x is equal to 1. Where is sine of x equal to 1? It's on the quadrantal, isn't it? 0, 1. What's that degree measure?
2 pi.
Ah, 0.
Well,
I know where you're getting at. Very good. Yeah, I saw where you're getting at though. In this case here, they're looking at, it's going to be at 0, and then every time you get back to 0, it's going to be your answer. So it's going to be 0 plus 2 pi n. Yes, sir.
Can you also just write it as 2 pi n? Would that work? Or do you have to put the 0 in front?
You put the 0 in front because n usually starts at more than one revolution.
Oh, so you could say that n begins off being 0, so it's just actually being 2 pi.
Then you have to define that, like where n equals, n starts at 0, you know, summations out. I mean,
You like n is 1 equals 0.
it's easier to write a 0 in front than plus 2 pi n than anything else.
Now, if you're going to write it that way, would you have to write 2 pi n and then subscript x and then say n1 equals 0?
Yeah, it would be more of a summation style. It's much easier to write 0 plus 2 pi
That's less fun.
n. Okay. Let's see, that was all those, I believe, right? Okay. What about the on the interval? How'd you do on those? Which one? What was it? 36 was the tangent of half, I believe. That's the one where you're gonna have to do the radian again with the calculator. How'd you do on that? Yes, sir. No. Or you were asking 40, weren't you?
yeah.
40? Let's look at 40. Yeah, I'll go back and do the one with the calculator here also. Okay. Excuse me. So in this case here, I have tangent squared equals sine secant. So I have to start kind of messing around with this a little bit to figure out what I'm going to do to start with. What's sine times secant equal to? It's tangent, isn't it? So this is tangent squared. Divide everything by tangent. Where do you have a tangent equal to 1? Pi over 4, very good. Yeah, there's a couple of ways of going about this one. Okay, there's a couple of ways of going about this. Yeah, that's what I was getting at. I was talking about.
But wouldn't you get that x equals the inverse tangent of the inverse tangent of 1 over 2?
How?
Well, you would add. Oh, I'm thinking 36.
Well, if you weren't on your phone, you probably would have caught up on it. Sorry. Put it away.
I asked. This one general is where now?
This one was within one revolution. This was the intervals where that's all you had to mix them out. Let's look at 36 then. 36 is the one that you had to use the calculator?
Yeah.
All right. So we have 10 tangent of x minus 5. So hopefully at this point you guys all got the part where it was tangent of x is going to equal a half. I'm assuming everybody got to that and was like, woohoo. Okay. That's where it starts. Now think about what angle or what quadrant are you going to be in?
The first and third.
Okay, so I'm going to be in the first and the third quadrant. I'm going to be there and there. So when I hit the inverse tangent button of 1/2, I need to make sure that I'm in radians. This is asking us to do this in radians because our interval was between 0 and 2 pi. So when we put our calculators into radians, make sure I'm in rendering. I'm in radians, so let me back out here. So inverse tangent of 0.5, and I hit enter. 0.46. I don't care what the degree measure is. I'm not really looking for it in terms of a fractional amount with pi in it. I'm just going to use 0.46. 0.46 is my reference. I know that's got to be in the first quadrant because it's positive. How do I get to the other side? Just add pi. So my solutions here are going to be 0.46 and 0.46 plus pi. And those are my only two solutions.
Is it pi? Is it pi n or just pi?
Just pi. Because I'm looking for this within one revolution. The instructions on this grouping is between 0 and 2 pi. So I'm just looking for it, where does this occur within one revolution of a circle? It occurred here, and then it will occur here because it's tangent positive in the third quadrant. And since what's nice is that I know that this is just plus pi to get here. Or if I use the ideas of bouncing off of this with the reference angle, I would get the same result. Okay. It works really nice with tangent. Yeah, tangent ones are pretty clean when you, even with the calculators, the calculator portion of it. What was the other one on there? Yes, 35.
I have a question.
Let me get back to that here in a minute here. We have to do 35? Yeah, we did 35.
Yeah, we
Yeah,
did.
we did.
No, we didn't.
With
I'm gonna assume,
Yeah, we did 34, 35, 36, and 40.
I'm gonna assume if we've gone over this much, we're not carrying.
Because I'm going to do more of it tonight. I'm going to give you guys some more factoring here in a second.
let's do it on the same sheet.
That's fine.
Because I'm running out of paper.
At this point here, does everybody agree I have to add 3?
Yes.
Okay.
And then you have x.
So x is going to equal the inverse tangent of plus or minus square root of 3. Are we okay with that? Which triangle am I in? I'm at 30, 60, 90. Which angle gives me the tangent of root 3 over 1? 60. The 60 degree gives me the root 3 over 1. So that means that it's at, I'm at pi over 3. Yeah, it's going to be in all 4 quadrants because of tangent. So to get the angle over here, that's really easy. Just add pi. So we start out with pi over 3. It would be 4 pi over 3. In the third quadrant, what's that? Well, because this is pi over 3, this is 3 pi over 3, so that'd be 4 pi over 3. Now when I go to the third quadrant, yeah.
Write it out as pi plus pi over 3.
When they're talking about within one revolution, you didn't put in n, did you?
No.
You're okay. That's fine. I know what you're talking about. Yeah, that's fine. I'm okay with that. Yes?
Where does it want to go to 2 pi?
Yes, that's what I'm getting to. The second quadrant is the 2 pi over 3. And then the fourth quadrant would be the 5 pi over 3. I think you got ahead of me when you were going through it, that's all. All right. So those are my 4 points where it works out.
Pi over 2 n?
No, this is an interval.
Oh, wait.
Okay. When you're on an interval, you're listing out your
Yeah.
points. Sir,
I thought tangent was negative in the second and the fourth.
it is.
Then why are you using it if it's
You are right. Yes, it is. Okay. Let me give you guys another one here that has a little bit more of the factoring. Oh, what number was it? Oh, I don't have it open. That's why. Let me get it out for you. Yeah. Let me get this out to you guys here. And we're going to discuss a couple of these problems.
There's no way I can get a big grade. I gotta get up to like a GD.
Oops, sorry.
It's a part of this year.
Let's take a look here. I've got some extra practice problems here. These were really nice as far as getting some extra factoring in here. Oh, let's see here. I want to look at number 12 on the A side. Number 12 on the A side. So I have 2 sine squared x equals 2 plus cosine of x. I'm looking to be on an interval, so I don't have to worry about tacking on anything here. Now's where things start to get a little bit more interesting. I've got 2 different trig functions here, sine squared and cosine. When I see this occurring, I'm going to try to manipulate this to put it all as one trig function, if possible.
Well, sine squared equals cosine squared minus 1, right?
Wrong.
Is this one going to go to
What is sine squared equal to?
cosine squared minus
1 minus cosine squared. So I'm going to rewrite this as 2 times 1 minus cosine squared x equals 2 plus cosine. Generally speaking, I'm going to try and keep these at the complexity of using one of a very straightforward Pythagorean identity. That's usually what happens with some of these. Okay. Now, the next step I would do, distribute. I get 2 minus 2 cosine squared x equals 2 plus cosine of x. Now, when you guys did factoring, I'm not there yet, I don't know. 2's not perfect square.
No, I mean, when you factor out, 1 minus
Yeah, but that's a good guess very far. Take a look at what I can do though. Remember how we always set one side equal to 0? And you wanted the highest power to be positive, correct? Coefficient to be positive. So take everything on the left and move it to the right.
So then you get 2 cosine squared plus cosine. You get 3. Because the 2's cancel each other out.
That's when you were verifying. We're not verifying, we're solving. The plus 2 on both sides drop out and we subtract it. I add the 2 cosine squared to the other side. I wind up with the following. Now, what's your first rule of factoring? Don't talk about factoring. After you go through that rule, what's the next rule?
Don't talk about
Still don't talk about it.
All right, well, let's not talk about it. Let's think about it.
I don't think we're allowed to do that either.
I take care of the GCF. From there, set both terms equal to 0. Cosine of x is 0. Cosine of x equals negative 1/2. Is everybody okay with me just moving that 1 divided by 2 right off the bat? Is that okay? Where do you get cosine equal to 0?
Oh, yeah, pi over 2.
Very good. Pi over 2, 3 pi over 2. This one is, again, on an interval. This was an interval problem, so it's between, we're having pi over 2 and 3 pi over 2. Where is cosine equal to negative 1/2? What triangle are we in? 30/60. So if I'm in the 30/60, I'm on the 60, so it would be at, the reference angle gives me a pi over 3. But I want it to be negative, so I'm in the second quadrant. So that's 2 pi over 3. And 4 pi over 3. Okay? What I'd like you guys to do is start up on number 9. There's some general ones there. So we'll do the ones on 14 for A for tonight. We'll do 9 through 11, so we just did 12. And then 13 through, bless you. 13 through 18. I will tell you a hint on 13. Write them as tangents. The other ones, if you have a sine squared and a cosine squared, or a sine squared and a regular cosine, or a cosine squared with a regular sine, try to rewrite them as the trig function with the lesser degree, if that makes sense. So if it's cosine squared and a regular sine, write them as sines. It's kind of like a little hint trick on these things. Give those a shot. We might actually spend a little bit more time on this tomorrow with some of the funkier ones on the other side with the inverses. Yes, sir.
Alright, just on this one.